Have you ever dropped a slice of toast? Butter side down, of course. Here on Earth, we're experts in falling. Things always go down, thanks to gravity. Gravity keeps our feet on the ground and our oceans in place. But look up. Astronauts float in the International Space Station. Satellites glide above us, and it seems like gravity has vanished. Here's the twist. Everything in space is falling. Astronauts, spacecraft, the moon, even Earth itself, they're all tumbling through space, pulled by gravity. What looks like floating is actually a cosmic dance. Everything is falling together. We're about to unravel why falling in space looks so much like floating. We'll explore what gravity really is, what space is like, and how the cosmic ballet works. By the end, you'll see the universe as a place of perpetual, graceful falling. The universe is in constant motion, and so are we. Let's talk gravity. On Earth, it pulls things down, but in space, down is just in, toward the center of mass. Gravity is a force of attraction between anything with mass. The Earth pulls everything toward its core, no matter where you stand. The moon, with less mass, has weaker gravity, but it's still there. The strength of gravity depends on mass and distance. More mass, more pull. Farther away, weaker pull. Gravity never truly disappears. It stretches across the universe. The Earth pulls on the moon pulls on Earth, and the sun pulls on all the planets. Even you exert a tiny gravitational pull on everything around you. Gravity is the invisible string tying the universe together. It's everywhere, connecting everything. That's the law. Now, let's set the stage. Space. We imagine space as a perfect vacuum, almost no matter, no air, no pressure. On Earth, air resistance slows things down. In space, that resistance is gone. The space between stars has just a few atoms per cubic meter, compared to the septillions in the air we breathe. But emptiness doesn't mean floating. People often think no air means no gravity, but gravity and vacuum are separate. Gravity is created by mass, not by air. The sun's gravity reaches Earth across 150 million kilometers of vacuum. If space canceled gravity, Earth would have drifted away long ago. The vacuum just removes air resistance, letting gravity act unopposed. That's why falling in space is so different, and so revealing. It's the key to understanding our floating astronaut puzzle. What happens when you drop two objects in a vacuum? Aristotle thought heavier things fall faster, but Galileo argued otherwise. In a vacuum, all objects fall at the same rate. The Apollo 15 mission proved it. On the moon, with almost no air, a hammer and a feather fell together side by side. Gravity pulled both equally. No air resistance to slow the feather. On Earth, air slows the feather, not gravity. On the moon, gravity's true nature was revealed. Everything falls together. This experiment solved a centuries-old debate. It's a critical clue. Gravity acts equally on all masses in a vacuum. The floating astronaut mystery? We're getting closer. In space, everything falls together. Here's the heart of it. Free fall. Free fall means falling under gravity's pull alone. No air, no engines, nothing else. In free fall, everything falls at the same rate, so nothing pushes back. Imagine an elevator cable snaps. You, the elevator, and anything inside, all fall together. You feel weightless. That's what astronauts experience in the International Space Station. The ISS isn't floating in zero gravity, it's in constant free fall around Earth. Astronauts and their spacecraft are falling together, so they feel weightless. Gravity is still there, but there's no ground pushing back. That's why floating in space is really falling in perfect unison. Free fall is the secret behind the space station's weightlessness. Zero gravity in space. Not true. Gravity at the ISS's altitude is still about 90% as strong as on Earth. If you stood on a 400-kilometer tower, you'd feel almost your full weight. Astronauts float because they're in free fall, not because gravity is gone. The term microgravity is more accurate. Tiny forces are at play, but gravity dominates. Everything inside the ISS is falling together, creating the illusion of weightlessness. Astronauts haven't escaped gravity, they're surrendering to it. They're floating as a coordinated plunge toward Earth. The final piece: how orbits make this possible. If the ISS is always falling, why doesn't it crash? Because it's moving sideways at incredible speed. An orbit is falling and missing the ground. Sideways motion balances gravity's pull. Throw a baseball hard enough, and as it falls, Earth curves away beneath it. It never lands. The ISS was launched with huge sideways speed. In space, no air slows it down. It keeps falling toward Earth, but always misses, circling endlessly. The moon orbits Earth the same way. Earth orbits the sun. We're all falling, but our sideways speed keeps us in orbit. Orbits are the perfect balance of motion and gravity. Why is everything moving sideways in the first place? It started with the birth of the solar system, a spinning cloud of gas and dust. As it collapsed, it spun faster, flattening into a disk. The sun formed at the center. The rest kept spinning, forming planets and moons. That original spin gave everything its sideways motion. In space, with almost no friction, that motion continues, thanks to inertia. The solar system's orbits are a fossil of its spinning birth. We're all still moving, still falling billions of years later. Picture yourself on the moon. Gravity is weaker, but you're not floating. You're pulled to the ground. The vacuum is total. No air, no sound, just stark sunlight and deep shadows. Try the Apollo experiment. Drop a rock and a piece of paper. They fall together, side by side. Gravity acts equally, unopposed by air. Look up. Earth hangs in the black sky, itself falling around the sun. You, the moon, Earth, and the whole solar system are all in constant, graceful free fall. Everything is part of a cosmic ballet, bound by gravity. You're not just standing on the moon, you're part of the universe's endless dance. Gravity, motion, and the vacuum connect us all. The universe is falling, and we're falling with it. If you found this information as fascinating and eye-opening as I do, then don't hesitate to smash that subscribe button for even more captivating science content.